Hello guys, this is Sumit Gaisas and I'm going to show you how to solve a slide puzzle blindfolded. So let's get started. What I have here is 8 puzzle. I haven't numbered them yet, but that wouldn't matter. So what I have here is green tile, blue tile and red tile. I'm going to perform a 3 cycle on them. What 3 cycle does is it shifts piece 1 to piece 2's position, piece 2 to piece 3's position and piece 3 to piece 1's position. So now the red piece will go to blue's position, the blue piece will go to green's position and the green piece will go to red's position. This can be done like this. It can also be performed the reverse way, like the green tile will go to blue's position, the blue tile will go to red's position and the red tile will go to green's position. So the important point to notice here is that except the pieces involved in the 3 cycle, no other piece gets affected, not even the blank tile. So this can be used to solve the 8 puzzle blindfolded. We'll start by defining some terminologies. We'll call this piece here the shooting place, this piece buffer 1 and this piece buffer 2. So what we do by 3 cycle is we'll shoot buffer 1 to the shooting place, we'll shift buffer 2 to buffer 1 and the piece which was previously at the shooting place gets buffer 2. So as everyone knows, this is my solve state, but for blindfold solving I will define this as my solve state. After solving every piece according to this solve state, I will perform this and this to turn it into the final solve state. So these will be the common end moves for every blindfold solver. So let's get to the actual algorithm. In this situation we can see that I have 7 in my buffer 1. 7 has to shoot here. So if I can get this 5 somehow to this shooting place, I will be able to shoot it and get it back without disturbing anyone else. So the algorithm is you perform a setup move to get the corresponding tile to the shooting place, then you perform a 3 cycle, then you perform a D setup move, which is exactly the inverse of the setup move. So this particular position, the setup move will be a clockwise rotation here, an anti-clockwise 3 cycle here, and we're done. Now the 5 is in the shooting place. Now I will shoot 7 to 5 by this 3 cycle. Now I will perform the D setup move, which is exactly the inverse of the setup move, which will be the clockwise 3 cycle here and an anti-clockwise 3 cycle here. As we can see, the 7 which was the buffer 1 is solved. 3 which was previously in buffer 2 is now in buffer 1 and 5 is in buffer 2. We will continue this procedure until we get the solved blind state. Now I have 3 in my buffer position. The correct position of 3 is exactly where it is right now. So what I do in this condition is I shoot this 3 to some unsolved piece. If you had done some Rubik's Cube solving, blindfold Rubik's Cube solving before, you would know this by breaking into a new cycle. This also applies to 6. Now let's take up this condition. Here I have 8 in my buffer 1. I have to shoot this 8 here in 5's position. Here the setup move is a little complicated. First I will do one clockwise 3 cycle here. Then I will get this 5 in a 4's position. Now as we can see, I have to get this 3 back in the buffer 2's position, which can be done by this. Now I will shoot the 8 at the 5's position. For undoing the setup move, I have to do exactly the inverse of the setup move. And we're done. Okay, let's take up this example solve now. The first thing I need to do here is put this empty tile in a center. Then I will put up a mental note that my sixth tile is here. Okay, so let's take up the memorization part. Right now I have 7 in my buffer 1, which needs to go here. Then I will have 3 in my buffer 1. So I will break into a new cycle by shooting it here. Then I will have 5 in my buffer 1, which needs to go here. Then I will have 4 in my buffer 1, which needs to go here. So now from my mental note I have 6 in this position. So I have 6 in my buffer 1, which needs to go here because I have to break into a new cycle. Now I have 1 in my buffer 1, which needs to go here. Then I will have 2 in my buffer 1, which needs to go here. Now if you think carefully, I had put 3 in this position to break into a new cycle. So now after shooting 2 in this position, I will have 3 in my buffer 2 and 8 in my buffer 1. So I will shoot 8 in its correct position here. But I had put 6 in this position to break into a new cycle. So after shooting 8 here, I will have 6 in my buffer 2 and 3 in my buffer 1. At this moment, I have blindfolded solve state. So all the memorization you need is sequence of shooting places, which is 1, 2, 3, 4, 5, 6, 7, 8, and we're done. Okay, so let's do it. The first shooting place is here. So I perform the setup move. I shoot. I get the piece back. The next shooting place is here. The next shooting place is here. Setup move. Shoot. Get the piece back. Next shooting place is here. Setup move. Shoot. Get back. The next shooting place is here. Setup. Shoot. Get it back. The next shooting place is here. Next shooting place is here. The last shooting place is here. And we're done.
Okay, so this algorithm applies to 15 puzzle too. There are 4 possible blindfolded solve states for 15 puzzles. One possibility is this, another is this, or this, and lastly this. For each of these possibilities, there will be one buffer position, or sorry, two buffer positions and one shooting place. Let's, for example, in this position, I can define this as my default shooting place, or I can define this as my default shooting place. For each of these combinations, I can have two buffer positions. For 12 as my default shooting place, I will have 15 and 11 as buffer positions. The complicated part here is how would you shoot this 15 here in these positions? Because shooting here will be just like 8 puzzles. But if I can convert these pieces in one of these pieces, I can shoot these pieces and get it back. It would just be like a second setup move. So let's take up the case where let's say I want to shoot this 15 here in 9th position. I can do that by first taking this 9 in this 6th position. Now 9 is one of these 8 puzzle positions. I can shoot this 9 easily by getting it to the shooting place, shooting it, getting it back. After this, all I need to do is reverse what I did before, and I'm done. So this method can be extended to solve any n degree, any n degree slice puzzle. But as you can see, this method is lengthy. very lengthy. And as we go from 15 puzzles to like 24 puzzles, it would be too boring to solve by just that. So there's one more very efficient, very fast method to solve these kind of slide puzzles blindfolded. If you know some theory, you would know this method by something called commutative conjugate. By applying some very simple commutatives and conjugates and some really simple setup moves, you can solve this slide puzzle very, very fast. So I would be posting my next video on this how to apply commutative and conjugates in these kind of slide puzzles. So for now, thank you.